Picture a lump of rock about the size of a potato. Now pack it with some of the most valuable metals on Earth.
At 5,000 meters below the ocean surface, where no sunlight reaches and the pressure could crush a submarine, scientists discovered something insane. It looked like just another deep-sea anomaly. But as the data came in, it became clear this wasn't ordinary. Something down there is defying the known laws of nature, and its estimated value, over $3 trillion.
That is an electric vehicle battery in a rock.
It looks like a lump of charcoal.
Governments are scrambling. Billionaires are quietly funding missions. And the scientists who found it are hinting at something that could rewrite everything we know about life on Earth. What they discovered 5,000 meters under the ocean is beyond anything anyone expected. The journey into the ocean's basement. The Clarion-Clipperton Zone, or CCZ, is one of the remaining uncharted territories on Earth. Located far out in the Pacific Ocean between the warm beaches of Hawaii and the coast of Mexico, covering 4.5 million square kilometers of seafloor, this enormous ocean plain is bigger than the whole European Union. Its depth, descending to 5,500 meters, where temperatures are barely above freezing, no sunshine has ever reached, and the pressure is 500 times more than at the surface, is what makes it foreign. We can't get much closer to visiting another planet on Earth than this. Mining-related companies were mostly interested in this puzzling area for decades due to the treasures that were strewn all over its floor. Nodules of copper, nickel, cobalt, and manganese that may be worth billions of dollars. However, a group of scientists from the Scottish Association for Marine Science, under the direction of Dr. Andrew Sweetman, visited there in 2021 with a completely different objective. They were pursuing air, which is considerably more essential to life than riches. The way the water flows through the deep-sea muck, where some of the most bizarre living forms on Earth manage to live in spite of all the odds, is more important than the gases in the water. Because it shows that life can thrive in seemingly unfriendly areas, the study team was interested in learning how air cycles through these harsh habitats. Microorganisms thrive in the mud here as well amid this dark, depressing emptiness and survive on little oxygen that slowly seeps down from the world above. Scientists might get a better understanding of deep-sea ecosystems and how human activities like mining may impact them by analyzing how these organisms use air. The researchers employed amazing devices known as landers, robotic labs that sink to the bottom on their own and carry out tests without the need for human assistance to reveal these mysteries. Benthic chambers, which are sealed receptacles that hold samples of mud and seawater, and oxygen sensors were among the specialized instruments carried by these landers. The idea was straightforward. Scientists could determine the biological activity in these deep sediments by measuring the rate at which oxygen is used by mud microorganisms. The sea, however, had other ideas. The equipment reported something completely nonsensical from the initial readings. The sensors observed an increase in air levels within the chambers rather than a steady decrease as the microorganisms used it. The scientists initially thought it had to be an error. One researcher observed, "You learn to distrust your instruments when you're working at these depths. Saltwater has a way of fouling even the best designed equipment. The tremendous pressure may distort metal, and the cold can impact electronics." Thus, they examined everything. They adjusted the sensors. The trials were conducted again. They dispatched fresh landers to several areas. However, despite their efforts, the unachievable outcome continued to emerge. Air levels were rising when they should have been falling. The crew had to come to the shocking realization that something on the bottom was going against the laws of nature in total darkness after 5 years of meticulous testing over several excursions. Everything was completely upended by this finding. Since plants and algae use sunlight to separate water molecules, we have always known that photosynthesis is the source of breathable air. This discovery in the sunless abyss was therefore analogous to the discovery of underwater fire. Radical explanations have to be considered by the team. Could certain minerals be releasing air through a reaction with seawater? Was there an unidentified chemical reaction going on? Or maybe a whole new kind of life that produces it in ways that we don't understand? The consequences go much beyond scholarly interest. The fact that oxygen may develop in the absence of sunshine and living things calls into question our fundamental knowledge of how deep-sea ecosystems work. In the early history of Earth, when the atmosphere was deficient in oxygen, it might help explain how life survived. It may even raise the prospect of discovering life on ocean worlds like Europa or Enceladus, where sunlight never penetrates, yet life-sustaining chemical processes could exist. The CCZ abruptly changed from being a promising mining location to a natural laboratory that revealed unseen processes. Miners' desire for such metal nodules might be a contributing factor to the enigma, since they may interact unexpectedly with saltwater. This discovery is an alarming indicator that, despite our current age of sophisticated technology, there are still plenty of significant puzzles in the deep ocean. The ocean's blueprint. The laws were changing on the deep ocean floor. A startling revelation descended upon the study team as they combed through the most recent readings from their deep-sea drones. The bottom was actively changing itself into complex geometric forms that defied all natural explanations. It wasn't merely inert beneath 5 kilometers of slapping black water.
That is a electric vehicle battery in a rock. It does, but it's a beautiful lump of nodule.
From the mud sprang spirals as accurate as the shells of nautiluses. Scattering outward like city plans are grids with almost perfect 90-degree angles. Mathematicians would marvel at the intricate tessellations created by interlocking ridges. The organization didn't match the mineral composition of the adjacent seabed. The rock itself seems to have chosen to fold into something more purposeful. Sweetman was constantly shifting his spectacles as though the pictures could shift. He said, "This isn't random erosion. This looks designed." Discomfort kicked in when the team compared images obtained just hours apart. The patterns were shifting, not radically, but definitely. Ridges stretching like slowly developing crystal fingers, grids enlarging their bounds, and spirals tightening their curves. As the seabed reconstructed itself with glacial care, they set up continuous time-lapse photography and observed in astonished stillness. "We're not studying geology anymore," a crew member said. "We're watching the Earth think in slow motion." The electromagnetic data showed a relationship that was much weirder. Minute variations in the local magnetic field matched each minor change in the patterns, indicating a deeper, hidden link between shape and energy. There was a clear pattern to the changes: a burst of energy, followed by motion, and then quiet. Again and again, like a sleeping giant's heartbeat. The squad ruled out every traditional explanation night after night. There were no heat signals that disproved hydrothermal activity. There were no chemical traces or gas emissions. The total lack of currents removed the effects of tides. There is indisputable physical proof of the force that was changing the ocean floor, even though it worked outside of established geological processes. When they looked at survey maps from decades before, it was the last terrifying detail. The archive data had always shown the patterns, which were less distinct and simpler. This was not a novel phenomenon. It had been expanding, growing. For what length of time was it evolving under human notice? And now that the researchers' cameras were focused on it, the patterns appeared to be shifting more quickly, as though they were reacting to their gaze. In the control room, there was an unanswered question. Were they participants or observers? Shutting down the living suspects. Finding the best logical explanation is the first thing scientists do when something unexpected occurs. The logical suspect in the odd oxygen readings coming from deep beneath the Pacific Ocean was life, namely, microbiological life. Despite its harshness and remoteness, the deep sea is far from dead. Microbes have been found in some of the harshest places on the planet, including underground in dry soils, inside Arctic ice, and even close to boiling hydrothermal vents. Many of these microbes can live without oxygen or sunshine. Rather, they depend on sulfur, methane, or iron-based chemical processes. Therefore, bacteria were the obvious suspect when Dr. Andrew Sweetman and his team from the Scottish Association for Marine Science noticed that oxygen levels were rising in enclosed chambers located deep below the Clarion-Clipperton Zone, CCZ. Was it possible that an odd microorganism was the answer to this enigma in the dark, while residing in the bottom sediment? The researchers started a fresh round of tests to verify this. In order to determine whether the phenomenon persisted, they set out to eradicate all life within the chambers. It was a deliberate approach. They applied biocides, which are substances made especially to sterilize habitats, to the benthic chambers, the apparatuses used to contain a sample of sediment and salt water on the ocean floor in controlled tests. By rupturing their cell membranes or interfering with their metabolism, these substances are known to neutralize microorganisms. In essence, the researchers were cleaning the silt to ensure that no living thing might skew the findings. This was an important step. After eliminating all biological life from the equation, if air levels were still rising, then something else, something non-living had to be to blame. Carefully, the treated chambers were once more lowered to the bottom, which is around 5,000 meters below the ocean's surface. The sensors sat in the dirt and started gathering information. The scientists waited back aboard the research vessel. Everyone anticipated that air levels would either stay constant or gradually decrease in the absence of any microbial activity this time. However, when the data returned, the findings were far from typical, and this would rewrite history. The oxygen content of the sterile, enclosed rooms increased as previously. Not abruptly, but unquestionably and slowly. The pattern was obvious. Despite the removal of all microbiological suspects from the scene, the odd trend continued. This was no longer only a strange readout or a malfunctioning piece of equipment. The observation was now routine, supported by strict control procedures and reproduced in carefully monitored settings. Nevertheless, it didn't make any traditional sense. The scientists intensified their efforts. They performed further controls. They used several techniques and dosages to repeat the sterilization. To eliminate local impacts, they shifted the placements and sizes of the chambers in various CCZ regions. However, the outcome was the same regardless of what they attempted. Where it shouldn't be, air was showing up. The mystery grew more complex. What else would it be if not microbes? Together with other oceanographic teams and experts, Dr. Sweetman and his associates started comparing notes. They spoke with geologists, chemists, and deep-sea biologists and examined historical datasets. Is there a chemical process that is generating gases? Was there a reaction between the silt and salt water that no one had observed before? Or was there a whole different explanation? Something we hadn't found yet. It was disturbing that there were no biological reasons. After all, in aquatic systems, life is typically the wild card. It may result in unforeseen consequences and confuse data. After removing the microbial card from the table, however, the researchers had to face a more difficult reality. They were observing a process that didn't behave like anything they had previously observed in investigations of maritime sediments. It was like pursuing a ghost. However, the data was honest. The same odd pattern continued regardless of how they altered the environment, including eliminating life, altering pressure conditions, modifying temperature models, and testing other areas. Inside caverns buried beneath thousands of meters of water, oxygen was slowly and silently rising. Simultaneously, the study team began to feel increasingly excited. This was the start of something far more significant than a singular occurrence. Whatever was causing the rise in air levels seemed to be extensive, dependable, and constant throughout their test locations. It was an occurrence that begged for a fresh interpretation. Now the researchers had a fresh question. Is there anything else the seafloor may be concealing besides economic potential? The enigma surrounding the increased oxygen levels persisted since there was no obvious biological cause, and traditional chemistry was unable to offer a satisfactory solution. The group continued working because they were curious about what unseen force was subtly changing the deep sea's chemistry, not because they were certain of their work. As of just now, they were certain only that something non-living was simulating the impact of respiration, exhaling air in the dark environment at the ocean's bottom. It was unexpected, whatever it was. The surprise was ongoing. An electrical clue. When Dr. Andrew Sweetman was at a deep-sea mining presentation in 2022, he heard something strange. A speaker casually referred to something discovered on the ocean floor as batteries in a rock. For Sweetman, it was the type of casual remark that puts a stop to everything.
This source of oxygen produced by these manganese nodules, and this is one from the bottom of the Pacific Ocean where Andrew Sweetman's been working.
Even though it was a cliché used to explain complicated mineral behavior, his study team had been gathering enigmatic data from the Clarion-Clipperton Zone, CCZ, a distant area of deep-sea topography between Mexico and Hawaii that is thousands of kilometers wide for more than a year. This area, which had previously attracted business attention because of its unexplored mineral resources, was now the center of an entirely other matter. However, mining was not on Sweetman's team's mind. Strange readings from the CCZ had been confusing them. The majority of scientists have previously regarded the lumps as inactive. However, what if they were active? The team was aware that the interaction of saltwater with some minerals can result in the production of small electrical currents. Their testing yielded startling, pun intended, findings. Under some circumstances, their specimen showed signs of little electrical currents, although not tangible. Not only was this fascinating, but it completely altered our perception of these deep-sea components. They may be more than just metal deposits. They may be active participants in their surroundings. This finding raises a ton of new issues. What effects does this electrical activity have on the odd animals that inhabit these zones? What part does it play in the chemistry of the deep ocean? Most importantly, what unanticipated consequences can mining these objects have on this fragile ecosystem? It turned out that the remark was more true than anybody had thought. It has served as a reminder to scientists that there are still mysteries we are only now starting to comprehend, even in the deepest recesses of the Earth. We should make sure we understand these surroundings completely before we begin to alter them. It appears that there are still many surprises in store for us in the deep ocean. As of yet, no team member was prepared to make public speculations. The science was still developing, and the phenomenon was still too elusive. However, what was previously dismissed as geological background and unrelated to the mysteries they were pursuing was suddenly receiving all of their focus. They had discovered a clue. Not a conclusion, however, it provided a fresh avenue for research, which is quite useful in the field of science. One that was unlike the others that were tried earlier. 1 volt from the void. Something unexpected occurred later in the laboratory on board the research vessel, which was hundreds of kilometers from any shoreline and hovering over one of the most isolated areas of the Pacific Ocean. Voltage differentials, current variations, and electrochemical gradients are all common observations for a deep-sea voyage, and the team had been doing normal diagnostics. The majority of the time, these unglamorous studies validated what scientists already knew. However, the equipment detected an oddity this time, a low-level, steady electric signal, about 1 volt. It may not seem like much. Compared to the electricity required to light a lamp, it is far less. However, it was enough to raise questions for scientists who had been working thousands of meters below the surface, where chemistry, pressure, and temperature are known to be stable and predictable. Where did 1 volt come from? No electricity sources were in the area. No organisms are big enough to produce the charge. Not a move. No warmth. It appeared like nothing at all should be generating energy. The current, however, continued to stabilize. Nor was this an instance of instrument mistake. The group performed many checks and even switched out some of the equipment. The outcomes remained unchanged. Deep in the shadows, something was driving electrons in one way. It was steady, slow, and silent. Like, you wouldn't see it unless you were looking for it. However, it was impossible to ignore now that it had been located. The possibilities of just 1 volt were even more fascinating. Even a little electric current may stimulate chemical processes under the correct circumstances. That's electrochemistry at its most fundamental. With sufficient time, even low voltages can significantly alter a solution's molecular composition. That's how seawater causes metal to rust. It is the process by which hydrothermal vents produce substances that support life. And it's the invisible way that energy moves across apparently inert regions. The crew was unable to determine what was initially causing this current. No moving parts were present, no biological agents like eels, no differences in temperature. There was nothing that fit the typical models. The surroundings themselves seemed weird, or maybe self-wiring. Among the crew, there were rumors of electrochemical reactions that had never been examined in this type of environment, and that might only be seen under circumstances and pressures that exist 5 kilometers below the ocean's surface. The researchers did not discuss the discovery. They just didn't know what to make of it yet, not that they were concealing it. However, the scientific community believes that even a tiny voltage in the deep water may have a huge impact. It alluded to opportunities that went much beyond the current objective. What if, in locations like this, energy were being produced organically in ways that were beyond our present comprehension? What if the deep bottom was something more dynamic, more active, rather than merely a cemetery of geological history? All of a sudden, the loudest signal of all was that 1 volt rising silently from the abyss. The secret of the breathing stones. Scientists have discovered one of nature's best-kept secrets in the deep Pacific Ocean. rocks that breathe oxygen into the ocean without the aid of sunshine or living things. This is insane and rewrites history. This shocking finding in the Clarion-Clipperton Zone, CCZ, a huge abyssal plain that lies between Hawaii and Mexico, is changing our knowledge of how oxygen moves across the most inhospitable places on Earth. Strange oxygen measurements from seabed tests in the CCZ perplexed marine experts for years. Sensors continued to detect oxygen levels inexplicably growing within their measuring chambers at depths greater than 5,000 meters, where sunlight never reaches and pressures might crush a submarine. This was illogical because photosynthesis from plants or bacteria powered by sunlight is necessary for all known forms of oxygen generation. Here, however, oxygen was showing up where none shouldn't. Dr. Andrew Sweetman's team from the Scottish Association for Marine Science has solved the case after years of arduous investigation. The seafloor's potato-sized metallic nodules hold the solution. As nature's deep-sea batteries, these polymetallic nodules, which mining corporations already seek out for their abundant manganese, nickel, cobalt, and copper deposits, are utilizing their power to separate seawater molecules. The procedure uses electrolysis, the same fundamental chemistry that industrial facilities employ to produce oxygen and hydrogen. When the nodules contact salt water under the intense pressure of the deep ocean, their distinct metal composition produces microscopic electrical currents. These currents are just powerful enough to split water molecules into their constituent gases, oxygen slowly bubbling into the surrounding environment, and hydrogen dissipating into the water. This dark oxygen synthesis is a completely new type of natural oxygen production. This is entirely geochemical, a chemistry and physics trick taking place in nature's high-pressure laboratory, as opposed to the biological processes we've been aware of for ages. The ramifications affect several scientific fields. It implies to marine scientists that deep-sea habitats could have oxygen sources we never thought about, possibly supporting life in ways we don't fully comprehend. The implications of this for the hunt for life on ocean worlds like Europa, where comparable metal-rich seafloors may produce oxygen without sunlight, are of interest to astronomers. Since such oxygen generation may have occurred before photosynthesis, geochemists now have to take this process into consideration when modeling the ancient waters of Earth. However, this innovation raises serious environmental issues. For planned deep-sea mining activities that aim to target these exact nodules, the CCZ is the epicenter. Mining may inadvertently change the oxygen levels that deep-sea life has relied on for thousands of years if it disturbs these natural breathing stones, with unknowable repercussions for one of Earth's remaining pristine ecosystems. Dr. Sweetman observes, this isn't just about scientific curiosity. A basic Earth function that was concealed in plain sight has been discovered by us. We must now comprehend it before we may interfere with it. These metallic deep-sea stones serve as a potent reminder of how much we still don't know about our planet as study continues, and why the last frontier could lie in the murky depths of our planet's seas, rather than in space. The finding forces us to reevaluate our basic understanding of the chemistry that supports life, as well as the conditions under which it may survive. History rewritten. The fundamentals of ocean research have been upended by the finding of dark oxygen. The production of oxygen, which is necessary for the majority of life on Earth, may now be accomplished without the need for sunlight, photosynthesis, or even living things, according to new research. Deep under the ocean, this chemical process has never been observed before, propelled by electrical energy from mineral-rich stones. It's not only a scientific advance, it's an epiphany. If this is how oxygen can originate in the most severe and gloomy places on our planet, what else may be possible? Previously believed to be inhospitable to life, Mars, Europa, and Enceladus may perhaps be more livable than previously believed. The catch, though, is this. The core of the expanding deep-sea mining sector is the same polymetallic nodules that cause this process. Businesses like the metals company are working to mine these old rocks for their rich metals, which are essential components for building renewable energy infrastructure and batteries for electric cars. This creates a serious conundrum. Could the removal of these nodules harm a naturally occurring oxygen supply that we hardly comprehend? Before we ever find ecosystems that depend on it, may we destroy them? A race against time evolved from what began as a quest to monitor the oxygen content of the bottom. There is now pressure on scientists to learn more about this secret system before it is destroyed or changed irrevocably. Once thought to be a dead desert, the deep sea is turning out to be far more vibrant and enigmatic than anybody had anticipated. We could have discovered the secret to comprehending life, not just on Earth, but also on other planets, 5,000 meters below the surface, under the quiet and pressure of the Earth's abyss. In every way possible, what scientists found is amazing, and it is up to us what comes next. If oxygen can form in the deepest, darkest parts of our ocean, do you think it could exist elsewhere in our solar system? Share your thoughts in the comments below. Thank you for watching this video. See you in the next one.